So far we have seen how we can create arrays, how we can do array basic operation on arrays. We have learned how to do slicing, indexing, shape manipulation. Now let's learn how we can join the arrays, how we can do merging of the arrays, how we can do splitting of the arrays. So let's first discuss about joining of the arrays. See, joining arrays means we are going to combine multiple arrays into and form a new larger array. So where is this useful? This is very useful when especially we want to combine data. So let's see different ways of joining the arrays through vertical stacking, horizontal stacking, and also combining one-dimensional arrays into multi-dimensional arrays. So let's first study about what is vertical stacking. So let's first create an array, right? Let's suppose we have two arrays, A and B. A is a 3x3 matrix and B is another 3x3 matrix. So what we are going to do is we are going to stack the array A on B. So there are two ways of stacking, vertical and horizontal. In vertical stacking, we combine the arrays vertically. That is, we add the second array's rows to the first array. Thereby, we are increasing the vertical dimension. But when we are doing horizontal stacking, we are going to add the second array's column to the first array's column. Thereby, we are increasing the array's horizontal dimension. So let's work this out on the Jupyter notebook to make it much clearer. Open the Jupyter notebook, go to New. So let's first import NumPy. Import NumPy as NP. Click on this run button. You can click on this run button or you can press shift enter. That will also do the execution. So after that, let's create an array. Let's say A is going to contain ones. It's a 3x3 array. Just type shift enter on your keyboard. It will execute. Okay, now there was an error in this. Okay, we are supposed to give one more brackets. Now execute. So you can see whether A is created correctly or not. Shift enter. Yes, A has been created. Now create one more array B. NP dot, let's call it as Z. Let's put 0 so that we can differentiate between the two arrays A comma B. Shift enter. Okay. So there's a mistake here. B is equal to NP dot. Okay, I can change here itself. I don't have to retype it. 3x3 and execute this again. Okay, so now B is an other array which is again containing, it's a 3x3 matrix with zeros and A is a 3x3 matrix with ones. Now let's demonstrate vertical stacking. So very easy. It's now this is again in the NumPy library, therefore you should say NP vstack. So within double brackets parenthesis you have to, let's say I want to stack A. First let's say I want to have at the base I want to have A and above that I want to have B. So then you have to give A comma B and then press shift enter. C. Okay, so A and then you have the B. So this is called as vertical stacking. So now let's say I want to do horizontal stacking. Shift enter. So you can see that it's just the reverse. So vertical stacking, what it is doing is it is increasing the vertical, the dimensions vertically. When you do horizontal stacking, it is increasing the dimensions horizontally. So thereby we are actually merging the arrays, right? So either you can go either of the methods depending upon what is needed for you. So coming back to the joining of arrays, so now we have seen how we can do horizontal stacking and vertical stacking. There are other methods of stacking also. So NumPy is actually provides functions for joining arrays in other ways. So you can stack one-dimensional arrays into columns or rows to create a new multi-dimensional array. So for that, NumPy provides some functions called as row underscore stack and column underscore stack. So column underscore stack is used to stack one-dimensional arrays as columns into a new two-dimensional array. So if you see this example here, column underscore stack, we can just try the same thing on the system to get a better idea of how this works. Let's go to the Jupyter notebook. Okay, now how do you do? Let's have now in this case we need to have one-dimensional arrays. So when you want to demonstrate row underscore stack and column underscore stack, your input should be a one-dimensional array. So let's first have three one-dimensional arrays. So let's give the values to this array. Okay, now create one more array like this. Let's call it as B with different values. Let's say 3, 4, 5. Let's create one more array called as C. See, note that here I am using all one-dimensional arrays. Okay, so now I have created three one-dimensional arrays. So now I am going to do column stacking. So how do you do? np dot column underscore stack, and then you call all the three arrays inside this, A, B, C. Shift enter to execute. So what happened here? You are creating multi-dimensional arrays, right, using three one-dimensional arrays. Since I have used the function column underscore stack, the columns are vertically you are increasing your dimensions. So first you put you have the 0, basically you are putting the columns of each unidimensional array next to each other, so column wise. Now let's try the horizontal stack. So just change this to horizontal underscore, or we call it as actually row underscore stack. Shift enter. See the difference. Okay, so basically where do we use the row underscore stack and column underscore stack is when you want to change the one-dimensional arrays and to create a new multi-dimensional array. So when you are using column underscore stack, you are actually increasing your stacking the columns of the arrays next to each other. When you are using the row underscore stack, you are stacking the rows one upon each other. Okay. Now coming to the next concept, so far we saw how we can merge the arrays. Now we can also split the array. So if you want to divide the arrays into multiple smaller arrays, then we have three important functions, that is hsplit, vsplit and split function. So hsplit will split the array horizontally, dividing the width into specified parts. vsplit will split the array vertically, dividing the height into specified parts. And split function offers more flexibility, allowing for splitting into non-symmetrical parts by specifying the indexes for division. So let's see this on the system. So before that, try to create a multi-dimensional array, because we want to split it. If I am using, after you created this 4x4 array, now we are trying to split it. If I am using the horizontal split, the first argument give the array which you want to split, and the second array I am giving as 2. So that means I am going to construct two 2x4 matrices. So that's the meaning. So here in this case what I am trying to do is I am splitting an array which is originally 4x4 into two 2x4 matrix. Okay, so after I apply this function, you can see B and C are created, which is actually 2x4 matrix. If you are using vertical split, Again the same concept, but now if you want to split the array vertically, meaning what? The height of the array is divided into two parts. The height is divided into two parts, and it will be split into two 4x2 matrix. So let's see this on the system. So let's first create a multi-dimensional array. So how do you create a multi-dimensional array? Let's say I have capital A is equal to np dot arrange. I will use the arrange function, and I will give the shape as 4x4. So now I have created a multi-dimensional array like this, 4x4. So this array I am going to split. So if I want to split, I want to split it into two. So that's why I am going to pass it into two. This function is going to return a value b comma c. It's going to return. So I'm going to call now np dot hsplit. Hsplit is the function. I want to split this A into two matrices. So that's why I give the second argument as 2. So that's all. You don't have to worry anything. So just give the first argument as the array which you want to split, and the second argument means how many matrices you want to make out of it. And since I have given here 2, it returns 2 matrices, and therefore I am giving b comma c here. See, now if I see b, so this is the B array which is created, and this is a C array which is created, right? So you can see that the first two columns have gone into the array A, B. The last two columns have been put into the array C. Now the same thing if you want to do vertical split. So just change this into vsplit. So let's say I will give this into other two arrays, D comma E. See, if you see D and this is E. So what has happened here? This is our original array. The first two rows are given into D and the second two rows are given into E. So vertical splitting is, it is reducing the dimension of the array vertically. So that's the meaning. Horizontal split is, it is reducing the dimension of the array horizontally. So that's the meaning. So there's one more function which is just called as split function. Okay, we saw head split, we saw vsplit. Now there's one more special function called a split function. Now this is a very powerful function which will allow us to split the arrays in a more controlled manner. I can also have non-symmetrical splitting. Okay, by specifying the indexes, I don't have to have a continuous splitting. We saw that in horizontal split I will have a continuous splitting. That we need not have if we can have non-symmetrical splitting if we just go for split function. So split function, the flexibility is, here we provide the array, we provide the indexes, where do you want to split, and here you will have one more argument as compared to hsplit or vsplit, which we call it as axis. If we say 1, it will be horizontal split, 0 means it will be vertical split, and there will be one more, that is a third argument. So let's see this. See here, we have created a multidimensional array, and this is how we have done the horizontal split and verticals. See, this is the splitting we have done here. This is a split function. Now there are 3 arguments to the split function. Okay, the first argument will be the array which you want to split. The second argument would be the index. You have to specify what exactly, which index that you want to take from that original array. And the third argument will actually help us to decide whether it is horizontal split or vertical split. If it is 1, it is horizontal split. If it is 0, it will be vertical split. Okay, so I'll repeat. Split function will allow us to split in a non-symmetrical way. There are 3 arguments to this. The first argument is the array which we are going to split, and the second argument is going to specify. We specify the index that is to be divided. Right? And the third argument is axis. If it is 1, it is horizontal split, 0 means vertical split. So see this example. This is the original array. Since I have given the index as 1, 3, and this is a horizontal split, what happens is horizontal dimensions will reduce, and it has taken the first column and it has taken the see here. It has taken the first column for array A1. it has taken the second and third column for array A2 and it has taken the fourth column for array A3. I'll repeat again. When you are using horizontal splitting, since I have given the index as 1, 3 here, the first column would be given to the array A1. The second and the third column will be given to array A2. The third column, the last one, the fourth column will be given to the array A3. Now, if I just change this to axis 0, the reverse happens. The first row would be given to array A1, the second and the third row would be given to array A2, the last row would be assigned to A3. So you are splitting your multi-dimensional array in a non-dimensional way. There is no fix, right? Each one is different. A1 is of different dimension, A2 is of different dimension. That's why we say this is split function is more powerful. It will help us to do non-symmetrical splitting, right? Each array is different from each other. Let's try this on the Jupyter notebook. So we already have a multi-dimensional array over here. So let's split this using the split function. So let's say A1, I want to split the array A into 3 parts. So that's why I'm going to return the function value to A1, A2, A3. Now I call the split function. np dot split function, and the first argument should be the array which you are splitting. The second argument should specify the index. So here within brackets you have to give, right, and it has to be a square brackets 1, 3. So when I give 1, 3, what happens is the first if it is a vertical one, the first column will go to A1, second and third will go to A2, the last one, that is the fourth column, will go to A3. Comma. Now axis you have to specify. If I give 0, it means it will be a vertical split. Now shift enter. So now let's see what is there in A1, what is there in A2, and what is there in A3. See, this similar like this, right? We have split the arrays like this because axis is 0, and you can see A1 is having the first row of the original array, A2 is having the second and the third row, A3 is having the last row. Now the same thing, I will just change the axis to 1. Okay, and now see, I will just try to execute this again. See, that's the benefit of Jupyter Notebook. You don't have to type the commands. You can rechange it, change it and execute again. So now you can see that when the axis is 1, the first column is allocated to A1, second and third column is allocated to A2, and third column is given to A3. So we saw that as compared to hsplit and vsplit, split function is more powerful. It's doing non-symmetrical splitting. So what we have learned in this session today is we have studied about joining and splitting of arrays in NumPy. We saw various functions like vstack, hstack, column stack, row stack, and also splitting functions like hsplit, vsplit, and split. So why do we use this? This is very useful, especially when we want to join data together, or we want to split the data, when we want to organize or manipulate the data within the arrays. This is a very important, useful function. It has a lot of applications. When you do projects, you realize lot of applications, especially in real world when it comes to image processing and data analysis. These functions plays a very important role. So I suggest that you all practice this in Jupyter Notebook and try to explore more functionalities and techniques which are related to these NumPy functions. Thank you.